Welcome back class 10th after the examination. Again we are going to continue our last chapter about which we were discussing, that was electromagnetic wave and spectrum. Before going to the next topic, I must inform you, or you can say you must be revived with that last topic about the chapter 2. In the previous lectures in the chapter we have discussed about first the electromagnetic wave. What is electromagnetic wave? Which consists electric and magnetic field. The wave which consists the electric and magnetic field together and which travels perpendicular. The vibration of this electric and magnetic field is perpendicular to the direction of propagation. Or you can say the electromagnetic wave is the simultaneous movement of electric and magnetic field perpendicular to the direction of propagation as well as perpendicular to each other. You have seen that electric and magnetic fields were perpendicular to each other too. Then after, the electromagnetic wave has a huge and broad sections. Means the limit of the electromagnetic wave is nothing. It's indefinite. But of the electromagnetic wave, a small section that is called visible. Small section of electromagnetic wave is visible. So that range is visible, that is from 8000 angstrom to 4000 angstrom. This is the range of visible electromagnetic wave. A light wave is visible. A light wave is electromagnetic in nature. Of that electromagnetic wave section, the small section is visible for us, starting from red to violet. Up to this we are able to see. Then we have discussed about the dispersion. Let's draw the diagram too. A white light, which is also known as polychromatic light. Poly means many, chrome means color, so many colors, light, mixture of many colors, that is white. When it falls on the prism, it splits into the 7 colors. So here are the 7 colors. So from violet to the red we will obtain on the screen. This phenomena is known as dispersion of light. The splitting of white light into its constituent colors or component of colors is known as dispersion. On this surface dispersion phenomena is going on. On this surface only refraction phenomena is going on. And why it is happening? Due to the refractive index. The refractive index of different color is different. That is why some means not some. The red is deviating least and the violet is deviating most. That is why they are splitting. The deviation of red is very less, violet is it's very high. So there is a splitting of light into its constituent colors. So we have already discussed about this. Now we are going to talk about the invisible spectrum. These from violet to red is visible for us. Why? These rays when fall on our retina, it excites our retina and we are able to see, or we can say we are able to recognize what color it is. This is not a color, just a wavelength, just a vibration, but our brain makes into, or you can say senses into its colors. So now I'm going to discuss about, suppose these are falling on our retina which gives electrical signal, so this is visible for us. Now suppose some wave, electromagnetic wave, I said it's a very having large range. Suppose any wave of electromagnetic section is falling on your eye but you are unable to see. It doesn't mean that it is not existing. That is not exciting our retina. If any wave is falling on our retina and which is not exciting our retina, means we are unable to see, not visible for us. So that is what? Invisible spectrum. So what you will say, you will say that the band of, or you can say the region of electromagnetic wave, or you can say spectrum, which do not excite our retina when these waves are falling on our retina. If do not excite our retina means not visible for us, and if they are not visible for us, so that is invisible spectrum. So now the point is how we will come to know that there is some spectrum as we are unable to see. How we will detect these are visible for us? So we can say that the wavelength of this, from this, the range, because it is visible. If something is not visible to us, how to recognize? For that, scientist named William Herschel, he did one experiment. What he did? Just think it. He put one thermometer here. Suppose this is the thermometer. And this thermometer is blackened. You can say the blackened bulb thermometer. Why? Because black will absorb all the wave band. As we have already discussed in this chapter, white and black are not color. White means all the wave bands are exciting our retina. Black means no wave band is exciting our retina. Same way, if we are going to do the making to the black, our thermometer, the mercury thermometer has shiny bulb, but when you will black it into the means you have to cover with the black color. That time you will say that is blackened bulb thermometer. So just place the thermometer at the violet color position. What will happen? Whatever the temperature is measured, suppose this is T temperature, is measured by this thermometer. Now shift the thermometer at indigo color. The William Herschel observed that there is an increase in the temperature. Then he moved to after the indigo blue, then green, then yellow, then orange, then red. At every further color, he found that the temperature was increasing. Now, if the temperature is increasing, on moving the thermometer further above, means higher the wavelength, greater is the heating effect. That's nothing big deal. That's quite natural. You can think that okay, we are going to the higher wavelength, the temperature is increasing. Now, when you are putting at violet, something measured. When you are putting at red, larger temperature, what he did, a new thing, he put the same thermometer after the red. And suppose here it is T1 and here it is T2. He found that T2 is greater than T1. Similarly, as we are going above, or you can say toward the higher wavelength, the temperature was increasing. He put above, just after the red color. What he found that T2 is greater than T1. You can say that if nothing is there, if no color is there, why the temperature is higher at that point? This leads to that topic. The spectrum is not visible to us, but it increasing the temperature of the thermometer. It increasing the value in the thermometer mercury level, you can say. Why? This points needs to be invisible spectrum. Here is what? Here it is invisible spectrum, and we have to name it. As we have named these visible spectrum, so what will be the spectrum which is lying above the red? The name will be what? With the name of red, that will be infrared. Remember this, infrared spectrum. So we are going to discuss now about the infrared spectrum. Again, what we have discussed, the prism spreads the white light. On placing the thermometer from violet to red, there is an increase in its temperature. After putting after red, putting the thermometer, we are measuring that still the increase in temperature means there is something which is not visible, which is not exciting our retina. So that is invisible spectrum, and we have named it infrared spectrum here. Now the point should be that The violet starts from 4000 angstrom and ends to 8000 angstrom up to red. So it is very clear that the starting range of the infrared range of wavelength for the infrared spectrum is starting with what? 8000 angstrom. It is very clear. Now where up to means the last range, the extreme end of this infrared, what is that? If you will use a glass prism, here listen that. If you are using a glass prism, so glass prism has some limitations. It can only pass the wavelength up to 20,000 angstrom. After that, if suppose this light or any invisible spectrum is passing through this, so that will be blocked. Only up to 20,000 angstrom wavelength will only pass. So suppose we don't know about this. So what we can say, the range of wavelength of infrared spectrum is from 8,000 to 20,000 angstrom. Listen, one more point it is, at this time I am talking that we don't know this point, that glass prism only allows 20,000 up to. Then some scientist, that is Langley, he replaced the glass prism with what? Rock salt prism. Rock salt prism. Mr. Langley used that rock salt prism. Then he found that the glass is allowing only up to 20,000, but this rock salt prism can allow further. And then we came to know about the range of wavelength of infrared spectrum, that is not up to 20,000, that is up to more than that. This is, see here, the actual range is 10 to the power 7 angstrom. Think, suppose if we are not knowing that about that, so we were assuming that means we can think that only the range up to 20,000 angstrom. But using this rock salt prism, we came to know about that from 8,000 angstrom to 10 to the power 7 angstrom is the range of what? The infrared spectrum. Now, how to detect the infrared spectrum? First, we can use blackened bulb thermometer. This is very easy thing. Means in examination it is asked that how you will detect that it is infrared spectrum or anywhere there is infrared spectrum. So what you will use? The blackened bulb thermometer. The answer, well, not only thermometer, blackened bulb thermometer. Second point that I am going to inform you, the mixture of two elements, that is called antimony and bismuth. See here, and set up like this. This is suppose antimony, then bismuth, then antimony, then bismuth, and number of series that you can set. Just join this with a meter, and these ends should, suppose we are placing in the hot chamber, and these ends we are placing this chamber in the hot and this chamber in the cold chamber, in the cold section. So due to the temperature difference, the antimony and bismuth flows, there is a vibration in the electron, so the electrons starts flowing from hotter end to colder end, colder end to hotter end. So there is a current in it. So suppose this hotter end is exposed to the infrared radiation. As we know that infrared radiation shows the heating effect. Suppose this section, this portion is placed into the infrared radiation section, and this is placed at the colder, or you can say normal temperature. So what will happen? There is a current. Means this device can be used to detect the infrared spectrum. So what is the name of this device? This device name is thermopile. So remember the two names. One is the blackened bulb thermometer. Second is the thermopile. These are the two devices which can be used to detect the infrared spectrum. Now the question is, what are the sources? Next point, source of infrared. The source of infrared is every living being. The one who has life is radiating infrared radiation. every time, every second, at every moment. Me even also emitting infrared radiation. Every body, every living being, like animal, plant, human, which has life, or you can say every object which has some heat inside, is radiating infrared radiation. The every bulb, every light source which produces heat is producing what? Infrared radiation. Now in examination, what will be asked? You should be asked to write the device to detect, then properties and uses. So device we have discussed, thermopile and thermometer, black and bulb thermometer. Now let's talk about the properties. Before starting the properties of infrared spectrum, I want to inform you, soldiers, in some movie you have seen that soldiers are using the infrared binoculars. See this photograph. In this photograph, you can see as higher the temperature of the subject, you can see the higher the wavelength emitting, and the temperature where is down, or you can say low, the color is going towards the violet. So that's the part of the infrared spectrum, or you can say infrared scanner, infrared camera. Now the properties of infrared spectrum. I want to inform you the first three properties which is common to all electromagnetic wave radiation. Common to all means in examination, if suppose is asked, write three properties of infrared, ultraviolet or visible, means any part of the electromagnetic wave. So these three properties are common to all. Those are, first, they travel with the speed of light, that 3 into 10 to the power 8 meter per second. Second, they are electromagnetic, so they are unaffected by the electric and magnetic field. And the third, they follow the law of refraction and reflection both. So these are the 3 points which is common for all the electromagnetic wave. You can write for any wave. But here we are talking about what? The infrared. So the next topic, next point will be regarding only about the infrared. The next thing is the range. It is ranging from the 8000 angstrom to 10 to the power 7 angstrom. Point 5. They are least scattered in the fog or mist. Means if you are taking the photograph using the infrared camera, so it will give you the clean image, rather than if you are using the normal camera, so it will not give the bright image, or you can say the clean image, that will be a little bit blurred, or you can say the capturing of the fog mist event. But why we are saying that infrared is having higher wavelength than the red event, means higher wavelength, so it can travel to the longer distance. That is why in the to take photograph in the fog or mist, we are using infrared cameras or infrared radiation camera. Next, that they do not affect the ordinary photographic film. If you know about the earlier time, the photograph was taken on the roll film. There was a film, a small size, on that photographs were taken. So that film was exposed to the light and it gives the photograph. But if you will use infrared radiation, when they will fall on that, so they will not give any photograph, or you can say not even any single spot, because they are unaffected by the ordinary film. So that will be used with the different type of, or you can say infrared, especially infrared film. Next, they can be detected by the thermopile or black and bulb thermometer, as they produces heating effects. So these are the properties of the infrared radiation, or you can say spectrum. Next point is about uses. So this point we will discuss about in our next lecture. Till then, thank you.